So let us start the integration, common integration only, where the formula will be bit more advanced. Like what I want to say, that derivative of sin mx is what? It is m cos mx, all of you know. One can write this as ddx of sin mx by m is equal to cos mx. You know, this is possible by the rule of differentiation only. We can keep m outside or inside, it doesn't matter. But when you want to write this one as formula, the formula going to be integration of cos mx dx will be sin mx by m plus c. Okay, this is our first formula. Integration of cos mx dx is equal to sin mx by m plus c. Now, derivative of cos mx, you know, minus m sin mx. If we do similar manipulation, integration of sin mx dx can be written as minus cos mx by m. So, in case of differentiation, we multiply the result by the constant with x and here we divide. You remember this manner, and let us rewrite the whole formula list for trigonometric functions and exponential functions at least. This is going to be cos mx by m plus c, and then integration of cosec square mx dx will be minus cot mx by m plus c. Integration of sec square mx dx will be tan mx by m plus c. Integration of cosec mx cot mx dx will be cosec mx by m plus c. Every time just it is being divided by m. Sec mx tan mx, this is going to be sec mx by m plus c. Okay, and the exponential one, other formula like x to the power n, keep it unchanged, dx unchanged, log x, dx by x, keep it unchanged, only this one, and the exponential one, like if you have a to the power mx dx, there I forgot to write a to the power x formula, please add it if I forgot to write over there, a to the power x by log a base c plus c. So here this is going to be a to the power mx by m log a base c plus c. In particular, if e to the power mx dx is there, no log factor will be there, it is simply e to the power mx by m plus c. Okay. So all these formula for integration available now, and we can start with variety of problems in integration to apply this procedure. Let us see the first example. Just integrate if just write number 1, say sin square x dx, or suppose root 1 plus cos x dx is there, root 1 minus sin x dx is there. Let us apply in solving these sums. Sin square x dx, how to integrate, because the previous class we have seen that sin x integration can be done. Sin square x, no product rule is there, so we cannot integrate, but here we can do it. Sin square x, all of you remember that sin square x in terms of some multiple angle, that sin square x, this can be written as half into 1 minus cos 2x, you know. Similarly, if it was cos square x, you could have written this one as 1 plus cos 2x. So this one, if you want to write, this will be half into, half is a constant. We have every right to take it outside the integration. This is by rule of integration. Then half will remain outside. Integration of dx minus half. So this will be half into x minus half into this plus c. Let us go for 1 plus cos x. You think what to do here? Inside root you cannot integrate directly, but is there any scope of changing this one to standard integral? We must try it first. So when you write 1 plus cos x, this you know 2 cos square x by 2. So I is going to be under root 2 cos square x by 2. Root 2 will come out. So there it will be sin x by 2 plus c. Root 2 sin x by 2 plus c. Independently you can try number 3. Then I'll tell you root 1 minus sin x you try. This you write as cos x by 2 minus sin x by 2 whole square. If you have arguments that why not sin x by 2 minus cos x by 2, then I have to tell you that the interval of x is given, then only you can decide. If it is not given, you can write anything. I forgot to put the range, I mean domain, where x is valid. So you can take the advantage. If you write it as sin x by 2 minus cos x by 2 whole square, I have nothing to say. Okay. If interval is given, after taking the square root, only positive sign will come out. Okay, that part I am coming in solving tricky sums. Here, just we write this way, or if you write sin x by 2 minus cos x by 2 whole square, it doesn't matter. I'll tell you that. So here, this under root, you are going to get this thing as cos x by 2 dx So this cos x by 2 will be sin x by 2 by 1 by 2 So take 2 as common. Sin x by 2 plus cos x by 2 dx. Cos x by 2 plus c. Now, question arises, this we have done for second part of cos or sine. I told you how to do. Is it possible to do if there is integrand where cube or fourth degree is given? Can we integrate that? Integrate Let us do these two. Cos cube x dx plus sine to the power 4x dx. How to integrate? No substitution, nothing. Whatever we have done, we will be doing based on that only. Okay? So our effort will be to convert this one to linear one. Because you know cos 3x equal to therefore 4 cos cube x will be cos 3x. See, how can I change it now? The first integrand cos cube x dx can be written as 1/4 cos 3x plus 3 cos x dx. So this thing changed to 1/4 plus 3/4 cos x dx. There will be 1/4 into plus 3/4 into sin x plus c. Okay. Can you try this thing? Check. I think all of you can do this also. Sin to the power 4x dx. Now it is in your mind how to convert a higher degree of trigonometric function to linear one and then to integrate. Okay. So for sin to the power 4x, I am going to apply this thing, that sin to the power 4x you write half into 2 sin square x whole square. So this is nothing but half into 1 minus cos 2x whole square. Just simplify it. 1 by 4 will be outside. But the problem is cos square 2x integration. We haven't done it, or we have done cos square 2x. Of course we have done 1/4 into 1 half into cos 2x. This one I will be writing as 1 by 8 into 2 cos square 2x. 1/4 minus half cos 2x plus 1 by 8 1 plus cos 4x. Now take 1/4 and 1 by 8 together. 3 by 8 half cos 2x. So substitute there. 3 by 8 half cos 2x now integrate term by term. Then it's coming. The answer going to be 3 by 8 into x. Cos 2x is sin 2x by 2 sin 4x by 4 plus c plus okay sin 4x by 32 plus c. This is the answer. So can we integrate sin to the power 6 this way? We can do 8, we can do, but for that other methods are deduced that we'll do in proper place, proper time. In the first chapter of your textbook, you'll find this kind of sums. In addition to that, I'm writing just one sum for practice, sums for practice. This you must try. Okay. And the third one is, the second one is cos 5x plus cos 4x by 1 plus 2 cos x.